in this case the model file, something like this. So we have symmetry about the z-axis here. Now we're modeling a nonlinear superconductor, so we're not, like in the previous case, we didn't have the nonlinear feature here. So once again, this is the air region. Okay, this is the iron, which I'm giving a permeability of 500 in this case. So not quite the permeability of new metal. The primary, once again, is copper, and these elements are connected in series. Okay, this is the superconductor. Now, in this case, since most of the field is going to be constrained to the ferrite, I've given a zero vector potential to the edge of the device. Now, I could have, like in the previous problem, we had an air region surrounding this. Okay, but I just wanted to illustrate that we can do this for if we need to conserve mesh spacing and so forth. Okay. So the problem's been solved for the case of the nonlinear superconductor, and in this case there is some ingress of the field into this. We can animate the solution, and you can see flux penetration in through the nonlinear superconductor here. Now, if we're doing a nonlinear superconductor, we have to be careful if it's got an opening in it. So we're going to have to either do two things. We're going to have to make it in a 2D simulation like this. We're going to have to make this where it's some sort of cup shape like this, or extend this out far enough where the sides are at zero vector potential on either side here. Okay. So let's look at the current that's flowing in the primary. In this case, I have something like 500 amperes, 550 amperes. And I want to go back and compare when the superconducting tube is screening it. Now modeling the superconducting tube as with a very small permeability. Okay, I'm going to resolve the problem. Which is considerably faster here when we're not including the nonlinear properties of the superconductor. I just want to look at the current that's flowing in the primary in this case, which is something like 700. So this really, as the tube is becoming normal, that's reducing the current flowing. So we have a higher current that's flowing in the unfaulted condition. And in the faulted condition, that's reducing the current as we would like to have. Okay. Finally, we can just see what the current in the primary would be if, in fact, this tube were completely normal. So I'm making it once again air. And we can see that there's actually greater flux penetration here. Okay, so this geometry would be sort of like a hollow dome, like a toroid. This is sort of a toroid type of geometry here with axisymmetry. And 118 would be the current in the primary in this case.